Terminator fans, Happy Trooper here with another fun project. In this episode, we will 3D print, sand, paint, and add LEDs to a T-800 model as seen in the Terminator franchise films. Even if you aren't a Terminator fan, this video may help you with finishing and painting 3D printed objects that require a polished aluminum finish. The goal of this build was to construct a relatively screen-accurate T-800 bust utilizing tools and materials that can be used in a homework area. The processes used in this video may seem exhaustive, but they should help you produce fairly decent results at home. Please feel free to change any of the methods and materials during your build. Do what you are comfortable with and what fits your budget. A quick note before we dive into the details. The STLs for this project were purchased from RenderHub.com. If purchasing the files isn't in your budget, there are plenty of free T-800 skulls available on other sites. The procedures that you'll see in this video can be applied to those models as well. The link to the files is in the description below. I'd like to thank Captain Lang from Morgan Elsbeth's forces. He happened to be time traveling at the same time that I was, under the name Kyle Reese. He said that he had some experience dealing with the T-800 and was able to provide some extra details. If you are using the same T-800 model that I'm using, you'll notice that there are quite a few STLs in the package. Here are some of the modifications that I made to the model. First, I did not print the CPU chip that goes in the skull tube. I only printed the tube cover. I also did not print the neck wires. Instead, I used some stripped coax cable that had the same dimensions as the 3D printed wires. I also skipped printing the eye lenses. Printing them vertically with clear filament does provide decent results. However, I found that cabochons with frost spray yielded better results. I changed the nameplate. Using the dimensions of the provided STL, I made my own plate in Tinkercad using the Skynet logo. I'll put the STL for this file in the description. I printed some supports along with the teeth. This aided in printing and kept them stationary while surface prepping and painting them. I also created some LED diffusers in Tinkercad. This aided in distributing the light from the LED bulb and kept the bulb centered in the eye socket. Lastly, I split the skull in half and printed it as two pieces. I wasn't sure if I'd be able to get the supports out of the skull. Perhaps one of you advanced 3D printers out there can share with the class a recommendation on how to print this skull in one piece while giving access to the cranial cavity. Once you've printed all the necessary pieces, it's time to smooth out those surfaces. Begin by sanding all of the pieces with 120 grit sandpaper. This will aid in knocking down those 3D print layer lines. Sanding twigs are helpful in hard-to-reach areas and when dealing with smaller pieces. Next, for the stand, skull, and jaw, use your favorite surface filler. When I'm dealing with large objects such as this, I prefer to use plastic wood. I mix it with a small amount of water so that it is the consistency of toothpaste. I can then brush it on. It takes a few hours to dry. After those pieces have dried, grab some more 120 grit sandpaper and begin removing the dried filler. Wood putty sands very easily. Once you see the surface of the prints, switch over to 220 grit sandpaper to begin the smoothing process. I really like this T-800 model, but it is not without improvements. For one, the detail lines are very shallow. I want to keep those details, but with all of the sanding, filling, and painting, it is easy to lose them. I recommend using some scribing tools to make those lines deeper so that they don't disappear. Don't put away the sandpaper just yet. Carefully sand those smaller objects with 120 and 220 grit sandpaper. Use sanding twigs for hard-to-reach areas. Note that I did not use any filler putty on the smaller items. I printed them at a 0.12 layer height, so surface filler wasn't needed. There are a few items that are difficult to sand, such as the teeth and the side head plates. For these items, I opted for Ecstasy 3D. You can also use UV resin or similar filler that will self-level and require little to no sanding. Mix 2 parts of A and 1 part of B and stir well. Brush the mixture onto the pieces. It will take a few hours to cure. Ecstasy 3D can be sanded if needed. I also used Ecstasy 3D on the skull areas where I was not able to sand, such as the nose and the recessed areas. There's one more round of sanding in this phase. Use some 320 or 400 grit sandpaper to smooth out the surface on all of the 3D printed parts. Not only will this smooth the surface, but it will still leave enough tooth for the spray filler in phase 2 of this project. If you have some old coaxial cable lying around, use it to make the neck wires. Cut 2 pieces of coax to a length of 9 inches or 23 centimeters. Use a utility knife to remove the sheath from the coax. Measure approximately 4 centimeters or 1.5 inches from one of the ends of the coax. Mark it with a piece of tape. Use a jacket stripping tool or other type of shear to remove the braided covering. Place an RG6 compression F connector over the coax. The connector should stay in place, but if you want a little insurance, cut a small piece of the sheath that you stripped earlier. Place it under the connector. It will make it more secure. Make a 90-degree bend in the top of the cable. I placed some cellophane tape on the bottom of the wire to prevent it from fraying. Some drilling is required on the skull. Drill a small pilot hole with a 1/16 or equivalent bit. Then use a 3/16 inch bit to accommodate the neck wire. Before painting the objects, let's do a test fit of all the pieces. You may notice that the fitment is on the snug side on some of the pieces. After a few layers of paint are added, the pieces may not fit at all. I used a pencil to mark off the areas where I didn't want paint. Disassemble the model. Use tape to block off any areas that don't require paint. Use clothespins or binder clips to hold the objects while painting and drying. Hit the objects with some compressed air to blow off any debris. For the objects that can't be held with clips, use some popsicle sticks and hot glue to make handles for the objects. I trimmed and folded an old clothes hanger to make a holder for the mandible. To hold the skull, I used a small piece of 1.5-inch PVC pipe with a few wraps of friction tape. This made a nice handle and stand for the skull. There are a few small areas that I want to block off during the painting process. I use some mounting putty to fill the CPU tube, the teeth holes, the skull rods, the mandible pistons, the teeth holes on the mandible, and the neck wire and skull rod holes on the base. Using a microfiber towel, wipe down all of the pieces with some rubbing alcohol to remove any oils that may affect paint adhesion. Finally, we can get over to the paint booth. It's a good idea to keep a tack cloth and some compressed air handy in case you need to remove any debris prior to priming. While priming and painting, I highly recommend wearing a respirator. I will be using Rust-Oleum filler primer to prime all of the pieces. Pretend that your spray paint can is a brush. Always keep it moving. Spray light coats over the objects. I applied 3 coats of filler primer, waiting 10 to 15 minutes between coats. When the objects look dry, it's safe to add another coat of primer. This stuff is pretty thick, so there's no need to lay it on heavy. The filler primer dries relatively quickly, sometimes as soon as 1 hour. I typically let it sit for at least 4 hours to be on the safe side. Now it's time to smooth out that high build surface primer with some wet sanding. Don't worry if the surface looks rough, we'll fix that in this step. Soak some 600 grit sandpaper in water. Thoroughly spray your object with some water. Sand the object using horizontal and vertical strokes, not circular. You are going for a smooth, uniform surface. If you see surface imperfections, you may need to apply some filler putty. At this stage, I like to use Bondo Spot Filler Putty. It dries in about 20 minutes, then it can be wet sanded with 400 or 600 grit sandpaper. For any parts that need an emergency Bondo, give the object one more coat of filler primer. The uniform gray color will reveal if you have successfully filled the imperfection. I don't want to lead anyone on in this project. I did use an airbrush to obtain this polished aluminum finish. Many of you are familiar with graphite powder rubs on top of a gloss paint base. I've seen a lot of fellow YouTube builders apply graphite powder to Mandalorian helmets with nice results. Graphite may be a good option here if you don't have access to an airbrush. Just be careful when applying graphite powder to the smaller objects, as they are fragile. I tested some graphite powder on a gloss black surface, and a gloss white surface to see which base color provided the best results. Both look good, however, a white base will provide a brighter metallic finish, which is what the T-800 looks like on film. The black base graphite rub looks great, but it is a much darker finish. I ran a test between airbrush metallic paint and a graphite powder finish over white gloss. Even with a white base, graphite powder is still on the dark side, no pun intended. Let's continue on with our painting. If you are going to be using graphite powder for your T-800, consider using a white gloss spray as your base coat. As I mentioned earlier, I will be using an airbrush to apply a metallic finish, so I opted for a gloss black base coat. Rust-Oleum Stops Rust Enamel in gloss black is the spray paint that I used in this step. Make sure your prime objects are clean and free of debris. Begin spraying all of the primed objects. Each object received 3 coats of paint. I waited 15 minutes between coats. The first 2 coats are light passes. The third coat was a little heavier. The third coat should look glossy. You want to avoid seeing texture on the third coat. Don't go too heavy or you may see runs in the paint. Again, I omitted spraying the teeth and the skull side panels in this step. Let all of these objects dry for at least 48 hours. I don't have any footage of spraying the teeth. I used Rust-Oleum Stops Rust in satin white to paint the teeth. I sprayed right on top of the XTC 3D filler. I gave the teeth 3 coats of paint, waiting 15 minutes between coats. A metallic finish really shines through with a smooth, ultra-glossy base coat. I'll be using Spray Max 2K Glamour to give all of the painted pieces a clear gloss coat. Spray Max 2K provides a beautiful finish, but it has a few caveats. It is expensive at about $25 per can. The pot life after mixing the clear resin and activator is 48 hours. Lastly, the fumes are very strong. Using a respirator is a must. If you are using an airbrush, another option is to pick up some no-name 2K gloss. It's about the same price as a can of Spray Max, but you control how much you want to mix, which would come in handy in a later step. You can still use a single-stage clear coat like Rust-Oleum Crystal Clear Enamel. Shake the Spray Max can for 2 minutes. Pop the red cap off of the top, secure it to the bottom of the can, and give it a smack, or 2, or 3. It can now be discarded. Shake the can for another 2 minutes. Begin applying the gloss in smooth, even coats. Apply a total of 3 coats with 5 to 10 minutes between coats. This could be considered the most important step of this project. Obtaining a smooth, glossy surface is imperative if you want to achieve a reflective metallic finish. 2K gloss is expensive, but it arguably provides the glossiest surface with minimal, if any, repair work after application. Allow the clear to cure for at least 24 hours. Applying a clear coat will give the objects more shine and will also provide a buffer if you need to apply clear coat corrections, such as wet sanding orange peel or dust nibs. In this next step, we'll see our T-800 start coming to life. Well, hopefully not. I will be using Spastix Mirror Chrome to apply my metallic finish. I'm using the medium needle on my Posh H airbrush with the compressor set to 15 psi. Spray all of the black glossy pieces. You'll want good uniform coverage of the mirror chrome. Ensure that you have a good light source while spraying. If you see uneven dark areas on your object, apply some more mirror chrome. At this point in the project, you have the option of stopping the painting process. The model will look great at this stage. However, that beautiful chrome paint provides zero protection. If you stop here, you must always handle the model wearing gloves, as fingerprints will appear on the finish. This paint is just sitting on the surface, just like a graphite powder rub. Note the following from the Spastix website. It will wipe away easily and will have no durability. If you do decide to stop here, just know that the mirror chrome is extremely fragile. Gently wipe off any excess mirror chrome using a microfiber towel. If you'd like to give your T-800 metallic finish some protection, stay with me. By adding additional protective clear coats, you will lose some of the reflective properties of the mirror chrome. Let's do our best to retain that nice finish. I'll begin by protecting the mirror chrome with some all-clad aqua gloss. Again, I use the medium needle on my Posh H airbrush and a compressor setting of 15 psi. The directions on the aqua gloss bottle say to apply 2 medium coats. If aqua gloss is applied in light coats, it will have a pebbly appearance, and that reflection will be lost. Gloss coats should always look wet. I never had much luck applying light coats. I stick to the recommended 2 medium coats. You may see it turn a blue milky color, just leave it alone, it will level and dry to a clear finish. I recommend practicing on some spoons or other practice pieces before spraying the T-800. Let the aqua gloss cure for at least 24 hours before moving on. You can also stop at this point too, but if you really want to pull that shine back out, keep watching. As you can see, the T-800 still has a metallic finish, but the all-clad aqua gloss has muted it a bit. Remember I mentioned earlier in the video about the no-name 2K gloss? Well, here's where it comes in handy. This 2K gloss can be sprayed over the cured all-clad aqua gloss. You must ensure that your T-800 objects have a thorough amount of aqua gloss protecting the mirror chrome. If there are any areas that do not have sufficient aqua gloss, the 2K will eat right through the chrome, leaving you with unsightly crackles. There is definitely risk and reward in this step. Now that the objects are protected, you can apply some weathering to bring out those details, and make your T-800 look a little battle-worn. I mixed some watercolor paint with some dish soap and water, and sloshed it in recessed areas using a paintbrush. I let it dry for approximately 30 minutes, and then wiped it off with a damp cloth. Damp cotton swabs are good in smaller areas. If you remove too much, just put some more watercolor on and let it dry again. To weather the teeth, I applied some acrylic paint using a paintbrush. I covered all of the teeth with paint. I let it dry for about 5 minutes and then removed most of it with damp cotton swabs. If you find that the acrylic paint is not coming off, switch over to some Windex window cleaner. It will remove the acrylic, but it will not damage the satin white spray paint. Remember, T-800s could have bad breath. They need the bad teeth and gingivitis to go with it. I've used this combination of paint on my R5 unit with great success. The satin paint has a little texture that the acrylic paint can latch on to. For me, the most difficult part of this project was the installation of the teeth. The teeth looked terrific, however, none of them fit into the gums. Each tooth required individual sanding treatment to fit into the tooth socket. Initially, I tried using sandpaper. However, I ended up using a rotary tool for quicker results. After each tooth was fit, I used some E6000 adhesive to secure the tooth into the socket. After installing the teeth, I realized that I wanted a glossier finish. I brushed on some Quick Shine acrylic floor finish. If you have some old bottles of Future or Pledge floor care in your cleaning closet, you can use either of those acrylics as well. Let's change gears and get into some electronics. To complete this step, you'll need a small power bank or other power source, a pair of red 5mm LED bulbs, a resistor, a USB cable with an A connector that is at least 18 inches or 46 centimeters in length, a soldering iron, and some solder. A breadboard and some shrink tubing is recommended. I had an unused USB cable on hand that will be perfect for the LED wiring. Cut the small end off, it will not be used. Measure about 5 inches or 13 centimeters down from the end that was just cut. Use some wire strippers to remove the sheath from the USB cable. You should see 4 wires. The white and the green wires that are used for data transfer on the USB cable are not needed. Go ahead and remove those. Strip a 1/4 inch off the ends of the red and black wires. We'll use these wires for power. You can use a multimeter to verify the voltage from the power bank. It should read about 5 volts. Now that we know the voltage of our power supply, let's build the circuit. Head over to ledcalculator.net. We know that the power supply is 5 volts. The voltage drop, also referred to as forward voltage for red LEDs, is 1.8 to 2.1 volts. The LED bulbs that I purchased have a forward voltage of 2 volts. If we run 5 volts from our power bank into the LED that is only expecting 2 volts, the bulb will blow out. Let's continue with the calculator. The LEDs that I'm using have a 20 milliamp rating, so I will leave this value. We'll be using 2 LEDs in the circuit. The results show that we'll need at least a 51 ohm resistor for our circuit. It doesn't have to be exactly 51 ohms, but it needs to be 51 ohms or greater. For example, you could use a 75 ohm resistor. I will check the circuit using a breadboard to verify that the LEDs are working prior to soldering the wires. An LED bulb has 2 leads. The longer lead is the positive terminal, referred to as the anode, and the shorter lead is the negative terminal, referred to as the cathode. You can place the resistor anywhere on the circuit. For my build, I'll place it first in line. I'll put one end of the resistor in a hole on the positive rail, and the other end in G55. I'll place the first LED's anode or positive terminal in F55 and the cathode or negative terminal in F45. For the second LED, I'll place the anode in G45 and the cathode in G35. I could have also placed this in the negative rail of the breadboard. I have a USB cable with male jumper wires to test the circuit. Place the positive jumper on the positive rail of the breadboard. Place the negative jumper in line with the second LED's cathode on row 35. Connect the USB cable to your power source to verify that the LEDs are working properly. Take a multimeter and verify the voltage of the 2 LEDs. It should be 2 volts or less. Everything looks good, so we can move to soldering. Here's the layout of the parts that require soldering. I will start with the USB power wire and work my way along the path that the electrons will travel. When dealing with small connections, I find that it is easier to tin each side of the connection. Twist the ends of the positive and negative wires. Place the positive wire in a set of helping hands. Clean the tip of your soldering iron. Apply a small amount of solder on the soldering iron's tip. Trace along the wire with the soldering iron tip and some solder to coat the wire. Only a small amount is needed. Repeat for the negative wire. Clean the tip again, tin the tip with more solder, and then trace along the wire. Let's move to the resistor. First, trim the leads on each side to half length. Repeat the same process that was applied in the last step. Clean the tip, tin the tip, and trace along the lead with the iron and some solder. Let's join the positive USB wire with the resistor. Secure the two objects in the helping hands so that they are touching. Run the soldering iron against the exposed wires and let the existing solder form a bond. Remove half of the lead on the positive terminal of the LED bulb. Tin the lead. Place some shrink tubing on the positive wire of the USB cable. Join the positive power wire to the LED's positive terminal using helping hands. Tin the soldering iron tip and solder the connection together. I used a breadboard jumper wire to bridge the two LEDs together. I removed the pins and then stripped both ends to expose the wires. Proceed with soldering and shrink tube placement. Use a heat gun to secure the shrink tubing in place. Insert the eyeballs into the skull and run the LED wires through the eye sockets. Place an LED diffuser on each bulb. Push the bulb back into the eye cavity. I sprayed some 13mm cabochons with Rust-Oleum frosted glass spray. They fit perfectly into the eyes. Secure the nameplate onto the base with some hot glue or E6000. The jaw pegs and mandible pistons did not require any adhesive, nor did the skull rods and neck wires. This build took a long time to complete. It felt great to cross the finish line with this T-800. I am thrilled with the results and will proudly display this with my other movie props.